This is section 1.6. 1.6 is going to seem a lot easier than 1.5. You'll get a lot of questions in this section about reduced echelon forms still, but you'll get questions more like, how many steps is it going to take to get this matrix into reduced echelon form? What are the steps that are going to get this matrix into reduced echelon form? Okay, so let's check out section 1.6. Very similar to 1.5. Make sure that you do understand what reduced echelon form is before you go into this section, though. Okay, so this section is about transforming a matrix to reduced echelon form. As I said, you've already transformed several matrices to reduced echelon form in the previous section, though, already. Okay, so you're going to find this section a lot quicker than the last, actually. All right. First of all, let's cover what the size of a matrix is. The size of a matrix is m by n, and that's where m is the number of rows and n is the number of columns. Now, you've probably already picked this up, but we talked about systems of equations if you had 3 variables and 3 equations and so on. But anyway, the size of a matrix is always rows by columns. You can think of RC Cola. I don't know if you've ever had RC Cola. It tastes a lot like Pepsi. But rows, then columns, RC. Okay, for example, if you have the matrix where the first row is 1, 2, 3, second row is 4, 5, 6, third is 7, 8, 9, fourth is 10, 11, 12, and fifth is 13, 14, 15. How many rows did I just say? 5. Okay, what about how many columns are there? There was the first column, second column, third column. Okay, so that's what size? It's 5 by 3. Okay, rows, then columns. Okay, so just to get that out of the way, now let's head into what this section is about. Now this is kind of a long theorem, but I tried to put it in plain English at the end. Let A be an m by n matrix. In other words, m rows, n columns. There is a unique reduced echelon m by n matrix B such that A can be transformed to B by a series of elementary row operations. Okay, i.e., in other words, what that is really saying is any matrix can be transformed to a unique meaning there's only one, reduced echelon matrix. Okay, this is actually good news for us. What it means is that any matrix that I give you, you should be able to use elementary row operations, in other words, Gauss-Jordan elimination, to get it into reduced echelon form. And it also means that whether I use different steps from you or you use different steps from someone else, we're all going to get the same end result. We're all going to get the same reduced echelon matrix in the end. Okay, so that's just a theorem telling us we can do this. We're going to get one correct answer in the end as far as what's reduced echelon form. Okay, so let's take a look at this example. Use elementary row operations to get to reduced echelon form. Okay, now I've given you kind of a big matrix here. Don't let it bother you though. You just have 3 rows and then 1, 2, 3, 4, 5, 6, 7 columns. Okay, you're going to find that this one is actually going to come out pretty quickly. All right, what are my goals? I want to get a 1 in the 1, 1 position. Always start with the first column. Make it look like you want it to look. Okay, if the first column's all zeros, then you'd move to the second column. All right, so I need a 1 right there. Now you can do that a couple different ways. I chose, because I don't like to do a lot of arithmetic, I chose to just switch row 1 with row 3. What that's going to do for me is it's going to give me a -1 up there, which is a lot closer than I was before. Okay, so I have a -1 where I need a +1. So what I would do next would be to multiply the first row by a -1. Okay, once I do that, I'm going to get 1, -2, +3, 0, 0, -4, -7 across the first row. Okay, now how's that first column look? Looks good, right? It's 1, 0, 0. Great. All right, now you move to the second column, or you move to wherever you could get your next leading 1. And the next place I could get a leading 1 is in the second column. Okay, well, check it out though. I already have a leading 1. Good news. I don't have to do anything with that. So I next would want to get the -2 that's above it to be a 0. You see I already have a 0 below it. Okay, so once I can get that to be a 0, that -2 to be a 0, second column will look good. All right, how am I going to do that? I'm going to do row 1 plus 2 row 2. I want to use that 1 that was below the -2. Okay, once I do that, you can see how that second column looks. Okay, first column looks good. Second column looks good. Okay, third column doesn't have a leading 1, so I don't worry about it. Fourth column doesn't have a leading 1. The next place I could actually get a leading 1, okay, in other words, in the third row, where can I get a leading 1? Where the 5 is. Okay, so I'm not going to mess with column 3. I'm not going to mess with column 4. I'm going to go to the next place where I could get a leading 1, and that's where that 5 is. How can I transform a 5 into a 1 without messing up some other stuff? Well, actually, in this problem, at all. How can I do that? Because there's no other way. You'd have to do 1/5 row 3. Okay, well, the good news is, once you do that, not only do you get a 1 right there, but if you look, it's the only non-zero in its column. So my first leading 1 was in the 1, 1 position. That column looks great. Second column looks great. The next place I have a leading 1 is in the 1, 2, 3, 4, 5th column. And that 5th column looks exactly like I want it to look. I don't need to check any other columns. Okay, that is reduced echelon form. You can check all 4 conditions. You don't have any rows of zeros, so you can say, yeah, they're at the bottom. Is the first non-zero entry in each row a 1? Yes. Do the 1s go down and right? Yes. And is that 1 the only non-zero? Is that leading 1 the only non-zero in its column? In each case, yes. Okay, so that's reduced echelon form. All right, next. This is a word problem. You'll see several in this section, especially if you do the written homework. There are 3 numbers whose sum is 34. Now, you've probably seen problems like this in algebra before. The sum of the first and second is 7. The sum of the second and third is 22. Find the numbers. Okay, now on this particular one, I'm going to get a unique solution. There's only going to be one possibility for each number. But there are cases where I might get an infinite amount of answers. And hopefully you'll have some more information to help you narrow it down further in those cases. All right, so what it's telling me here, since those 3 numbers add up to 34, then x1 plus x2 plus x3 is 34. The sum of the first and second would be x1 plus x2, that's supposed to be 7. And the sum of the second and third is 22, so x2 plus x3 is equal to 22. Okay, now staying consistent with the way we do things in this class, we would throw that now into an augmented matrix. The first row would be 1, 1, 1, 34. Second row would be 1, 1, 0, 7. And then third row would be 0, 1, 1, 22. In the upper left-hand corner, I want that to be a 1. Hey, check it out, it already is. So now I want to get all zeros below it. So since the third row looks good already, having a 0 there, I want the second row also to have a 0. Okay, so where the circle is, I want to have a 0. What I'm going to have to do to accomplish that is row 2 minus row 1. If you remember, what we want to change goes first. So row 2 we want to change, write that first. Okay, after you do that, row 2 minus row 1, you can see I do 1 minus 1, 1 minus 1, 0 minus 1 gives me a negative 1, 7 minus 34 gives me negative 27. Okay, so now first column is perfect. Move to the second column. Can I get a leading 1 where that 0 is? Yes. There's a couple ways you can do it. Like I've said before, I don't really like to do a lot of arithmetic, so my choice was to switch row 2 and row 3. Okay, that gave me a 1 in that position and a 0 below it, so no arithmetic there. Otherwise, I would have had to do some arithmetic to get the 1 and then do some arithmetic to get rid of the other 1. So this kills two birds with one stone, pardon the expression. All right. I have a 1 now in the leading 1 position in the second row, but I need a 0 above it. I have a 0 below it, need a 0 above it. So I want the 1 in the first row, second column to be a 0. I can use the second row to accomplish that. So I want to do row 1 minus row 2. Okay, if you see here, that gives me a 0 in that position. Okay, next. See, the second column looks great, right? I want to get a 0, I'm sorry, a positive 1 where the negative 1 is. Well, that's easily done if you'll just multiply that row by negative 1. Okay, so negative row 3. Then I have just one more step. I want a 0 in the second row, third column, because I want the leading 1 that was in the third row to be the only non-zero in its column. Okay, so if you'll do row 2, because that's what you want to change, minus row 3, because that's where the 1 is located, those nice little zeros in row 3 are going to cause you not to mess up your 0 and 1 from before. Okay, so now, is that reduced echelon form? Let's check. Are my rows of zeros at the bottom? Well, sure, because there aren't any, right? What about, is the first non-zero entry in each row a 1? Yes. Does the stair-step pattern go down and right for the leading ones? Yes. What about, is each one the only non-zero in its column? Well, it better be, because that was like the main rule I used as I was doing this thing. Okay, so it's reduced echelon form. We're now ready to write out the solution. Okay, now going across, you can see that that says that x1 is 12, x2 is negative 5, and x3 is 27. So the three numbers I was looking for are 12, negative 5, and positive 27. So as you saw, that was a unique solution. Okay, try some of these problems in section 1.6, not only the ones that ask, well, how many steps does it take to get it to reduced echelon form, but try some of the word problems as well, because they're going to get a little bit tougher, and I'll try to show you some word problems in the future sections as well. Okay, good luck with section 1.6. I think you'll find it relatively quick, especially after you've done section 1.5.